Hey guys, is it sad to watch your own videos? I mean, I feel like it kinda is, but whatever, I'm doing it anyway. So, Chemizel here with another chemistry video. Today, I'll be teaching you stoichiometry, which is pretty much the bloodline of chemistry. You can't do much without stoichiometry. You're not gonna get far. So this is muy importante, and it really combines everything we've learned so far, so that's kind of cool, right? And before I go any further, stoichiometry hails from the Greek words stoic, which means pain, and iometry, which means theos. So stoichiometry, pain, theos. Every stoichiometry problem, really every chemistry problem, has a given, which is what the problem says, slash gives you, hence given. That was tough. And a desired, which is what the problem asks for, what you have to find. So yeah, given and desired, those are just basic terms I'm assigning to that. Tu comprende? Fantastic. Now we can move on to the 4 simple steps of how to solve stoichiometry, or as I like to call them, the 4 stoichiometry commandments. Because, you know, that just sounds a lot more demanding. But yeah, anyway, these are the 4 steps I came up with to just solve any stoic problem easily. Teachers will tell you different stuff, but I think this way is a lot easier than what they try to teach you. So the first thing you do is find the moles of the given. Oh, remember what that is? Given. Oh yeah, what the problem says. So find the moles of the given. If you don't know how to do that, click the link to the mole video linked somewhere, because you need to know how to find moles before you can do stoic. So yeah, click over there, come back here if you don't know how to do that. Step 2 is find the molar ratio, which is merely the coefficient of the desired over the coefficient, I don't know how to spell, of the given. Yeah, you've probably never heard of that before, but it's really easy. It's literally just coefficient of the desired over coefficient of the given. That's all it is. And step 3 is that's not how you spell. Multiply the moles of the given by the molar ratio, which essentially is step 1 times step 2, because, you know, we found the moles, and then the molar ratio, so just multiply those two together. And the final step is, if you did them right, steps 1 to 3 should give you the moles of the desired. If the problem wants grams, just multiply by the molar mass, or molecular mass, same thing, of the desired. And if you don't know how to do that, you gotta click on the moles video once again, or the molecular mass video, depending on which one you don't know. If you don't know both, click on them both. Fantastic. So those are really, that's it. These are the 4 steps. Boom, bang, bong, bing. Like I said, teachers will tell you something different. They'll make it more complicated, but that's it right there. Do. And I'll show you the way teachers do it too. Just so you know both ways, and you can decide which one works best for you. Yay, options. Okay, one thing I want to clarify really quick. You need a balanced chemical equation to do any stoic problems. You need one. That should be step 1, but I didn't make it a step because normally the problem gives it to you, but if for some reason it doesn't, you need that before you can do anything, and that's what I'm referring to when I say coefficient. Like the coefficient from the balanced chemical equation. So you need this before you can do any of this. Great. Sample problem. I just typed up, yeah, the window. There. I just typed up this problem. I got it from one of my old things, I think. Packets, something, I don't know. But yeah, so here's the problem. Let's do part A. So, step 1 is find moles of the given. And the given is 2.24 grams of NH3 ammonia. Yeah, so to find moles, like I said, you don't want to do that, click the video. but here's pretty much how you do it. Moles equals grams over molecular mass. Plug in what you know. We're trying to find moles, so moles equals 2.24 over 15, because 15 is the molecular mass of ammonia, NH3, and that'll get you, I don't know, I guess I have to like find a calculator. I'll be back. Okay, so I found a calculator, and this is 0.149, which I'm just going to call 0.15. So that means we have 0.15 moles of NH3. Look at that, 0.15 moles of ammonia. Cool, that's like the answer to step 1. Step 1 equals over, so we'll make it bold. Step 2 is then to find the molar ratio. Find the molar ratio, which, if you recall, is the, I don't know how to spell, so coefficient of the desired over the coefficient of the given. And to find that, we must look at the balanced chemical equation, which was given to us. And NH3 is the given, and for part A, NO is the desired, so 4 divided by 4, so Fo over Fo equals 1. Boom, that's the end of step 2. Bold that thing. Step 2 done. Oh my gosh, there's only 4 steps. That means we're halfway done. And on a new page now. So step 3 is to multiply moles given by molar ratio, which we found moles given in step 1, and that was 0.15 moles of NH3 times the molar ratio, which we just found, which is 1, times 1, which gives us 0.15 moles of NO. So that's the desired. That is how many moles of NO will be produced from 2.24 grams of ammonia. Multiply grams, multiply the molar mass by moles. Wow, that was a mess to say. Okay, so the molecular mass of NO is 28 grams. For like the 5th time, if you don't know what the heck that means, check out the other video. 28 grams times 0.15 moles moles of NO equals 4.2 grams of NO. And that right here is the final answer. And yeah, so that's how you do it. Let's just take a quick perusers. We found moles of given, we found a molar ratio, we found moles of desired by multiplying given by molar ratio, and then we found grams of desired by multiplying moles of desired by molecular mass. And that's how it's done. Part B. So yeah, part B. This time we're trying to find H2O. I'm going to go through it quick this time because, well, we just went by it step by step. So for B, I'm going to go quick. I'll still write out all the calculations though. I'll slow down for that part because that's new to you guys, probably. Molar ratio, so it's desired, coefficient of the desired, 6, or coefficient of the given, 4. So that's where you got molar ratio 6 over 4. So that's my method of doing it, the four stoichiometry commandments. That's how I do it. I think it's easy, it's quick, easy, painless for the most part. And here's how the teachers probably taught the you to do the Who, Doctor Who, Winnie, Winnie the Pooh. This is how the teachers taught you to do they Who, Doctor Who, Winnie the Pooh. What the hell's wrong with me? To do they do Who, Doctor Who, Winnie the Pooh. They probably said, so you got to write to the given here, 2.24 grams, and then you write it down here, then up there, then down there, then up there, then down there, then up here, and right there. So that's how they taught you to do it. I use this method too sometimes. I just don't write it out all the way. It is easier because you can see the whole problem. But for quick problems like this, like it's literally just 4 little calculations. I don't necessarily waste the time writing it all out, but it is a good skill to learn. So, you know what? This is a lot to talk about. I'll make a whole another video for this called Factor. What the hell? Factor labeling dimensional analysis. I'll make another video for that later. But right now, so if you see it like that, don't get confused. That's just a different way to do it. I like my 4 stoichiometry commandments, but that way is also good. So I'll make a video explaining that later. So thank you for watching. I hope this video was helpful. If it was helpful, be sure to share it with anybody that you think needs help with this subject. Yeah, share with anybody that needs that needs help. Check out my other channel, News JMC, linked somewhere, and feel free to look at the other subjects covered in my playlist so far. Boom. Oh, wait. No. Alright, now it's News JMC. That's what the News JMC logo looks like. There we go. Okay, so yeah, anyway, I've just been ranting for a while now. Thanks for watching. I'll see you next team. Ciao. Ciao? I'm not Italian. Well, I am Italian. I'm half Italian, half Japanese. I'm a Jap Italian.